Here are some examples using composite functions. Composite functions means that I have a function inside of another function, and we always start working from the inside. Here I have tangent inverse of square root of 3, and what this is, this whole thing inside the parentheses, is the angle. Okay, we're looking for an angle, and then we're going to take the cosine of that angle. Okay, so we need to find what this angle is, and this angle here we can find using our unit circle and knowing that for tangent inverse, I can only use either quadrant 1 in the unit circle or quadrant 4, okay? Because that keeps me within the restricted range here that I'm able to use for tangent inverse from negative pi halves to pi halves. So what's the tangent inverse of square root of 3? You have to memorize these values for tangent. I know you've memorized the sine, the cosine, which is your x-coordinate, the sine, which is your y-coordinate. Those you know. Now, you need to add to your repertoire, you need to add the tangent values also, okay? So square root of 3, the tangent, the angle whose tangent is square root of 3, that's pi thirds, okay? So this piece here is pi thirds. So I can rewrite this as the cosine of pi thirds. And since square root of 3 is positive in this case, then I'm in the first quadrant. So it has to be pi thirds. And then I can easily say that the cosine of pi thirds is the x-axis of pi thirds. That equals 1/2. And you're done. For example 2, tangent inverse of 0. We're looking for an angle, and once we have that angle, we can take the sine of that angle. So the tangent inverse of 0 is asking you, what angle do I take the tangent of and get 0? That will occur wherever sine is 0, because sine will be your numerator for tangent and cosine will be your denominator. So if sine over cosine is going to equal 0, that means sine has to be 0. So where is, on the first or second quadrant or on the axis, sine equal to 0? It's right here. So this piece here is 0. So we can write that the sine of 0 equals. So now what is the sine of 0? What is the y value at 0 radians? It's 0. So this equals 0. And that is 1/2, okay? Next example. We're looking for tangent inverse of negative square root of 3. The same thing as the first example, except now this is negative. So that would place me in the fourth quadrant. And remember that these values, we're not going to use these values. We're going to use the equivalent, which is negative pi 6, negative pi fourths for this one, and negative pi thirds, and negative pi halves. Okay, so negative square root of 3, what angle do I take the tangent of and get negative square root of 3? That happens at negative pi thirds. So this piece here is negative pi thirds, so I can rewrite tangent, this tangent here, of negative pi thirds. And now I take the tangent at negative pi thirds, and what do I get? I get negative square root of 3. Okay, there's actually a property, a cancellation property for tangent inverse. And it says that this will equal whatever this value is as long as this value is between your x values, or, well, in this case, any number. This will equal to whatever number you place here, this will equal that number, okay, for tangent inverse. Next example. Cosine, here we just simply do the cosine. Cosine of negative pi fourths, we look for pi fourths, negative pi fourths right here. The cosine is your x-coordinate. So this piece here is equal to positive square root of 2 over 2. So I can write tangent inverse of square root of 2 over 2. That's what this comes out to. And now tangent inverse of square root of 2 over 2, it's asking you at what angle do I take the tangent of and get square root of 2 over 2? Well, that you need your calculator for that, because tangent inverse of this value, we don't know. Okay, I almost said it was pi fourths because as soon as you see square root of 2 over 2, you think of pi fourths. But remember, square root of 2 over 2 is the x coordinate and it's also the y coordinate, but it's not the tangent. Okay, so here we're looking for an angle where my tangent will be equal to this. And tangent is either equal to 1, 0, square root of 3, square root of 3 over 3, numbers like that that we know from our special values. We didn't use square root of 3 over 3. We can do one with square root of 3 over 3, which is at pi 6. But this value here, I don't know how much that is on the unit circle, so let's use our calculator. I would have to do tangent inverse. Okay, I'm going to do the tangent inverse of the square root of 2, close parentheses, and close the other parentheses, and divide by 2. And that's your answer, 4777. 0.4777. Okay, so be careful here. You don't know an angle from the special angles that you know where you'll get a tangent of square root of 2 over 2. Okay? And there it is. You're done with the composite functions. I hope you understood this. If not, go back, try them on your own. Always try these on your own and check your answers. This is a 0. I'll see you in the next video where we'll discuss cosine.